Alright, today's lesson we have topic 6.4 trapezoids. In this lesson we will define what a trapezoid is, look at a couple of sketches. We will define also the parts that make up a trapezoid. We will look at a formula to find the median, and we will use our definitions and properties as well as the formula to solve problems related to trapezoids. Alright, so let's go ahead and get started in our notes. We have our first page and we have our terms. Our terms, which we have here that are defining a trapezoid. Our trapezoid is a quadrilateral with exactly one pair of parallel lines. So, if we come over here to draw a trapezoid, I'm going to start out. I'll call these two lines parallel. Now what you're going to find is this, we're not going to have that much of a slope here on this section, but here, one of these two will go out much further. So our parallel lines in this instance, we will have right here, this is one pair of parallel lines. Alright, we have bases. I'll try to redraw somewhat similar figure to what I've got up here. And for our base, we have two bases. We can call this one up here, I tell you what, let's snag a different color here. We have base 1. Sure, that kind of looks like a 1. And a base 2. So we have two bases, the tops and the bottoms. Our bases, if you look, and it has right here, the definition is the parallel sides. So if you turn this figure, if we were to rotate this figure, we had something similar to this. Well, this would be our base number 1, and this would be our base number 2. These are still our bases. Our figures are our parallel sides. This is parallel with this. Alright, our legs. Let's go ahead and redraw our figure. Our legs are the non-parallel sides. So, let's see here, snag a color here. We've got two legs in this instance, but I'm not worried about that. We just have a leg here and a leg here. Alright, base angles. Angles at the bases. Okay, so if I was to redraw, we have our angles here and here. Notice I put 1 and 2 because they are not congruent. Nothing tells us that they are congruent. Our base angles are simply our angles that they're at our bases. Okay. So let's look at some examples and let's find what it's asking us for. Here it's saying find the value of x for the trapezoid. Alright, now let's think back to our definition real quickly. Trapezoid, the definition is a quadrilateral with exactly one pair of parallel lines. Quadrilateral. Defining a quadrilateral will tell us that these angles do what? They equal 180. If y'all go back in your notes, you can look at that. All of our quadrilaterals, they have the angles will add up to 180. So, if we know they add up to 180, let me go over here, grab a color. We can take our first angle, 12x plus 3, when added together, so plus 13x plus 2 equals our 180. So we've got, if we combine this, 25x plus 5, 25x plus 5, combining our like terms equals 180, subtract 5. 25x equals 175. And doing the calculations, x then equals 7. Now we're looking for the value of x. There's our final answer. All right, we have another term here. We have the term is median. By definition, a median is a segment that joins the midpoints of the legs of a trapezoid. It is also parallel to the bases. So let's go ahead and draw. Let's draw a figure. We'll go ahead and draw a trapezoid. Now, let's see. It joins the midpoints of the legs. So I'm going to go ahead and look at, here's a leg. Here's a leg. Midpoint. Midpoint, what's the special thing we know about midpoint? Midpoint is the middle. That's right in the middle of these two. That means this is congruent with this. So we have our midpoints. And I'm going to go ahead, I'm going to draw our median. Now, what else does it say about it? It is parallel to the bases. So if I took and I made this an arrow and I made this an arrow, I would also need to make this an arrow. All right. Let's look below here. It says to find the length of a median, use the formula. All right, so we have a formula coming up. Our median formula. It is, see how to write it on there. So we can do it this way. We have base 1 plus base 2. And we're going to use this whole line right here. This line will be our divided by 2. So also, if you wanted to come over here, maybe you wanted to put B1 plus B2 divided by 2. Base 1 plus base 2 divided by 2. Big key thing to remember right here. Base 1 plus base 2 divided by 2. Alright. So, here's a base. Here's a base. To find the length of this median, we would need to know these two lengths, and then we will divide it by 2. Alright, let's take this information and let's move on to second page of our notes. We're example 2. Okay, trapezoid. Alright, we already know what this figure is. It is a trapezoid. A, B, C, D, E, F is a median. I'm going to go over here and I'm going to say, well, this is parallel, this is parallel, this is parallel. Just something we already know. Find each of the following. A, B equals 25. Alright, so I'm going to say, also, here's another thing we know we can mark. If you remember my colors from a while ago, this right here is midpoints. That means these will be congruent. These two will be congruent. We can go ahead and write that in. Let's see, AB, this whole length here is 25. 25. DC is 13. Now we want to find EF. Right back to what we just used, the formula for finding the median. We use base 1 plus base 2. We have B1 plus B2 divided by 2. So in this case, we have a 13 plus 25 divided by 2. We have a 38 divided by 2. So what does that give us in the end? Well, a 38 divided by 2 would give us a 19. So our answer to this would be 19. Go up here and write it in. 19. Alright, let's see, AE, it's now giving us AE. AE is equal to 11. FB is equal to 8. AD, well, we already know that this is equal to this. So we know that this is now 11. Now this is 8, just in case it asks us. Now it's asking us for AD. It's asking us for this entire length here, which we know is 11 plus 11, or 22. So AD is, ooh, don't want that color. AD is a 22. BC, well, we know the same thing for over there. BC would then be a 16. AB is now 29. Alright, so it's giving us some information where let's go ahead and erase out my previous work. Giving us all new bits of info here. Let's still leave my parallel lines and congruent lines, because that stays the same no matter what. But now it is giving us that AB is 29. And it also is giving us EF is 24. And it wants us to find DC. Alright, the formula, B1 plus B2 divided by 2 equals our midpoint, or our median. Excuse me, not the midpoint, the median. Now in this formula, let me go ahead and let me change this around. M equals, our median equals this. What information does it give us? It gives us our median. So if I was to rewrite this, I would say 24 equals. Now, does it give us base 1? It doesn't really matter which one of these we call base 1. I'm going to say base 1 is what we need to know. We don't know base 1. We're after base 1. So x plus, now do we know a B2? Yes, 29 divided by 2. Alright, to work this out, multiply both sides by 2. That will cross out here and here. Leaves us 48 plus, or I'm sorry, equals x plus 29. Subtract 29 from both sides. We'll get a cancel out on this side. And over here, looks like we are left with a 19 equals an x. Hey, there we go. So now DC equals, we just solved it, 19. Alright, I'm going to quickly erase here because it's giving us more information. I realize it'd be very tough for y'all to keep up with that in this manner, but most of the time, if it gives you a figure, just write, you can write really small, or you can just work it out to the side. Here, it gives me AB, and it gives me 7y plus 6. 7y plus 6. EF, it's telling me, is 5y minus 3. And lastly, it gives me DC is y minus 2. Solve now for y. Alright, it's going to be pretty small here, but I'm going to write M equals B1 plus B2 divided by 2. Let's substitute in what we have. Okay, so we have our M, which it tells us is a 5y minus 3. Now we have equals. Do we know a B1? Yes, it's y minus 2. Since we're adding them together, I'm not going to worry about putting them in parentheses. Because our second one is a 7y plus 6. And we know that we do all of this divided by 2. Alright, this is about to get a little bit longer here. We're going to multiply both sides, of course, by 2. So we're going to multiply both of our numbers over here by 2, which will leave you with a 10y minus 6 equals. Now I'm going to go ahead to save some space. I'm going to combine my like terms up here. I've got a positive y, positive 7y, 8y, negative 2, and a positive 6. 6 minus 2, you can think about it that way, it's 4. Alright. Now, let's get our y's. Our y's on one side, so let's subtract 8y. And if we're going to subtract 8y over here, let's go ahead and add 6, because that'll remove this. We'll be left with 2y equals 10. Y equals 5. Alright, so we're here and grab this and say y equals 5. Alright, measure of EAB. Now this is one of those key things I told you. If you look at this, that looks like it's 90, but you cannot take for granted in these questions, because these questions are going to just test your knowledge of stuff. EAB right here is 63 degrees. It wants to know the measure of DEF. Alright, so what we're going to look at, and let's see here, if we go back in our notes, let's see if it's anywhere that it tells us anything about this situation, because what it's going to come down to is these are going to create two similar. Let me go ahead and show you here on this. Let me grab a color. What's going to be created by these angles whenever we put in the median is we will have this. We will have these two right here, which are congruent, because if we, let's say we take, here we go. I'm going to draw this out. This is something we've actually learned previously. There's me a parallel line, and here's me a parallel line. And this line here, here's my transversal. So let's look at where our lines are at. If this was a line that continued on, this was a line that continued on, they're corresponding. They're on the same side of our transversal, but they're neither both interior nor exterior. They're on the same side, and they're in the same position. So they're corresponding. Definition of a corresponding angle, they are congruent by definition. Therefore, this is 63. DEF is also 63. So we will use the transversals, we will use everything that we learned in our previous lessons. Similarly to this, this will help us solve problems such as example 2E. Alright, example 3, find the value of x for the trapezoid. Alright, this is one of those similar things that I told you a while ago. It doesn't matter if it's turned up. These are still our bases. Our bases are parallel. So this is technically B1 and this is B2. Either way, B1, B2, B1, B2. Doesn't matter what order. These are still our bases. So our x is this point. This is our median. And we know our median equals B1 plus B2 divided by 2. Median here in this case is an x equals 24 plus 34 divided by 2. X equals 58 divided by 2, so that will leave us with an x equals 29. We want to find the value of x. Problem solved. Alright. Let's let's look here at some of our properties, in which we've already gone over all of this. So let's go ahead and put it in. Exactly one pair of parallel sides. Alright, so there's our pair of parallel sides. Now, what we also do know is that this is also parallel. But now we know our median. Median is 1/2 base 1 plus base 2. That's the exact same thing as what we've been saying. We can write it in as 1/2 B1 plus B2. But it's the same as going base 1 plus base 2 divided by 2. When you multiply by 1/2, you divide by 2. When you multiply by 1/3, you divide by 3, so on and so forth. Alright, so let's move on to the next page of our notes. We have another term here. The term is an isosceles trapezoid, which the definition is a trapezoid with congruent legs. If you remember our isosceles triangle, you'll know that the definition was a triangle that had two congruent sides. So, it is the same in this instance. I'd go over here and I'd draw trapezoid. Typically your legs will go in, that way they will not be parallel. But what it's saying here is these legs are congruent. This is equal to that. Alright. And here we have an isosceles trapezoid. Has all the properties of a trapezoid plus a few more. Alright, so let's go ahead and draw in what we're going to know about these. It says we have exactly one pair of parallel sides. So, here's obviously our parallel sides. Alright, our median. So I'm going to draw a median in here. Try to cut this in half as best we can. Go over here and add some colors to our median. So we'll deal with in a red. Alright. Our legs are congruent. Just our legs, that's all it's talking about. These are not our legs, these are our bases. They are not congruent. So our legs are congruent. Our diagonals then become congruent. Not a green. Here we go. So we drew two lines on that one. We can also come over here and we can draw two lines here. Now what it's dealing with on this is whenever it's saying our diagonals are congruent, it's not talking about the little sections like this section and this section. It's every bit of this, our entire diagonal as one, from here all the way to there. That is our entire diagonal, which is congruent to this other diagonal. Alright, and lastly, our base angles are congruent. So if this was our base 2, well, these angles on our base 2 would be congruent. I don't need that little dot there. As well as this is our base 1, well, these angles, our base 1 angles will fall in and be congruent with each other. So these two angles are congruent, and these two angles are congruent. So let's take that and let's move on down. ABCD is an isosceles trapezoid. Okay, so they gave us a bit of information. We know that all this we just looked at is true. Decide whether each statement is true or false. I don't know why it's asking us that, because what we're going to actually find here, what it's asking for, is our measures. So let's go ahead and let's go in our notes. Let's take maybe I cover it up here. I'm not worried about this. I'm not going to define whether or not they're true or false. We're going to actually find what our missing value is. So I'm going to come over here and I'm going to put in ADC 54. It wants to know BCD. Well, we know this is congruent with this. I'm going to actually go ahead and add these in as well. These are as well congruent. So if we know these two are congruent, that's very easy of 54. Now we also will know that these are corresponding, don't we? So these are congruent. And these as well are corresponding. We can look at a lot of information here. BAD is 112, 112. What is BCD? BCD, well, its definition of a trapezoid is that it is quadrilateral. Therefore, these would equal 180. Now, if these two angles would equal 180, and D and C are the same, then essentially what we would be after, let me go ahead and erase this because that does not hold true in this instant. What we're after is if we find what D is, we also find what C is. So our D, which I'm going to just label in here as an X, we don't know what it is. X plus 112 equals 180. Minus 112 minus 112x then equals 68. So it's a 68. This is a 68. Once we know the definition of the trapezoid, that's how we then knew that if these angles right here, they are congruent. So well, if we find one, we find the other. We also know that by the definition of a trapezoid, it's quadrilateral. So that these two angles would add up to 180. Now, let's look. The thing that you have to be careful on, as a quick note, is that obviously these two angles, they do not equal 180, do they? That's 112 and 112. Now, the reason being is they're not part of our parallel lines. These are not parallel. So, in instance, what we can all go back to is our two parallel lines. So here's a line that extends on, and here's our transversal. These two lines, in that instance, are what? They're same side interior. Knowing same side interiors, they are supplements. They add up to 180. That's how we can say that. So don't get too carried away with the absolute definition of the quadrilateral, where these two will add up to 180, because that is obviously not true in this case due to the parallel lines, and that is why it's the parallel lines. These are not parallel. That will not hold true. Alright, let's look at our last one real quickly. It tells us the measure of ABC. ABC is 95. What is ADC? We can solve that the exact same way. We know that these two right here will equal 180. So, let's go ahead and put in, we don't know this one, but once we find it, we'll find this one as well. X plus 95 equals 180 minus 95 minus 95. X should then equal 85. 85 degrees. Alright, so let's move to our last page of notes now. And look at two more examples. Example 5, DONE, done, is an isosceles trapezoid. It tells us that EDO, this entire angle here, which we know, this is what we know. Go ahead and write that in. Alright, so EDO is 110 degrees, and DEN is a 15x minus 5. Find the value of x. Alright, with these two right here being our parallel bases of the trapezoid, we then know that these two will equal 180. (15x minus 5 plus a 110 equals 180. 15x, combine our like terms, plus 105 equals 180. Subtract 105 minus 105. 15x at that point equals 75. Divide both sides by 15. You will find that x equals 5. Find the value of x. Problem is solved. Alright. Example 6, our last example. I've scrolled down just a little bit. Example 6, TRAP. T-R-A-P is an isosceles trapezoid. I'll go ahead and mark what I know. See if this makes it a little bit easier on us in just a minute. We also know that this is congruent to this. These two sides are congruent. Now this is a little bit extra, but this will just help us see everything that we're looking at. PR. So this entire length here is a 3x minus 7. And TA, so this one is 20. Hey, looky there, I just already marked that these two are congruent. We know this. So, if they're congruent, they're equal. If they're equal, I can say 3x minus 7 equals 20 plus 7 plus 7. 3x equals 20. 27. Divide by 3, x equals 9. Alright, and we're going to try to find the value of x. So, there's a lesson over trapezoids, isosceles trapezoids, using the information given with the properties, with the definitions. Go back if you need to the images that we go over, the pictures that are drawn with the properties, and carry these over just like what I did right here. That's all this is. This is the picture that we did on the page before. It tells us these diagonals are congruent, these two sides are congruent, these sides are parallel, and it tells us these angles here are congruent and these angles are congruent. So you can go back to that and you can solve these equations.